Okay. A tow truck weighing 10,000 newtons is pulling a car of mass 600 kilograms at constant speed. The 5,000 newtons of friction on the wheels of the tow truck propel it forward. Okay. All right. So again, I see the keyword constant speed, so I know that the forces are going to be balanced. Okay. And I'm going to have car, truck, ground, and earth. Okay, so again, just like in the last problem, I wouldn't think of that wire as being anything separate. Just think of it as part of the truck, okay, because then it's just cleaner, because then the truck and the car can directly interact, okay? And since they're moving to the right, okay, I would say that that's more of a pull, right, because the truck is the one doing the driving, right? The car is just kind of being dragged along. All right, so I would say that's more of a pull than a push, right? If the car was the one doing the driving, then the truck would be being pushed, but that's not what's happening, okay? All right, so same thing like the other ones. The truck and the ground are going to have a normal, and since he's able to drive, it tells you the friction on the wheels propels it forward, so that's a friction, okay? And then the car has a normal, and the car also has a friction. Okay, and we'll kind of assume, again, that this car is just sort of being dragged. These wheels aren't really engaging, right? They're just kind of being dragged along like this, all right? And then everybody can have a gravity, even the ground if you want. Gravity, okay? All right, so let's take a look first at the car. Okay, the car is having 4 interactions, all right? I realize that all of these all have 4 interactions, but they don't always, okay? I thought there was one more. Oh, I thought there was a harder one than this. This one's not even hard. Okay. I swear there's another one. We'll see. Okay. All right. So here goes car. Okay. So force, gravity, car, earth. Okay. And force, normal, car, ground. Right? Because the ground is pushing up on the car. Okay. The truck is pulling the car. So how does the car feel that? Okay, so the car is feeling it this way. Okay, the car is feeling the force this way. So force, tension, car, truck. Okay, and then if it's moving at a constant speed, there's going to have to be a friction this way. Force, friction, car, ground. All right. Okay, so let's see if we can get some numbers in here. Do we have enough to do anything? Okay, a tow truck, no, is pulling a car of mass 600 kilograms. Okay, so since that's in kilograms, I have to multiply by 10 to get the weight. So this is going to be 6,000 newtons. Okay, 600 kilograms becomes 6,000 newtons. So this is going to be 6,000 newtons. Okay, and we really don't have anything else here. So let's go ahead and start the truck, and then we'll see what happens. Okay, so the truck is also having 4 interactions. Okay, so it's going to have force, gravity, truck, earth. Okay, and force, normal, truck, ground. All right. The tow truck is pulling the car to the right, which means he is feeling that pull to the left. So force, tension, truck, car. Okay, and it says that the friction on the wheels, that engagement of the wheels against the ground, is what's propelling this forward. Force, friction, truck, ground. Okay, and this is the one that it tells us 5,000 newtons of friction propel it forward. So this is the one that's 5,000. All right, so if we know that's 5,000, then we know the tension has to also be 5,000 because it's at a constant speed, so the forces are balanced. All right, we need the weight of the tow truck, but here again, look, it gives it in newtons already. Okay, so that means it's already ready to go. It already is a force if it's measured in newtons. Okay, all right, so that means this is going to have to be 10,000 newtons. All right, and this is not really to scale very well. Okay, now I have to look for the pair. All right, so I have car and truck. So I'm looking for the one that has the car and truck feeler dealer, and there it is. Okay, so this guy and this guy are going to be a pair. I know this is 5,000, so this has to be 5,000. And since the forces are balanced, then this also has to be 5,000. All right, so there you go.